Recursive function in Python is a function which is going to call itself during execution. So far we have seen we define a function and we call it somewhere outside. And if you find inside the body of a function, if the same function is being called, then that is what we call as your recursive function. Now let's see what is the basic structure of a recursive function. So we start as usual with the def keyword followed by the some function and some parameters. And here we write some condition. And the condition is nothing but called your base case. So we write some if, some condition, return some value. And then in the else part, I am going to write the recursive case where we are going to call the same function once again within this body. So this is completely the body of the function. Inside this function, we are going to call the same function with some modified parameters. Now, whenever we define a recursive function, we need to take care of two features. The very first feature is there is a case called base case, or this is a condition. Base case is nothing but it is a condition for which the recursive call will not happen. So when this condition gets satisfied, your completely the function call or the recursion is going to stop. So unless until you write a base case inside the recursive function, your execution of the function may get into an infinite loop. It is never going to stop. And coming to the recursive case, where the function is calling itself with some modified parameters. So initially, this function would have been called with a particular parameter, but later stage, the same function will be called again and again with some modification done to the parameter. If there is no modification done to the parameter, and once again, this recursion will take you to an infinite time of execution, which is never going to stop. So each time we define a recursive function, we have to look after two things. One is a case, one condition for which the recursive call will not happen. And the second one is you call it recursively by passing some modified parameter. Now let's understand this by taking a very simple example of finding factorial using recursion. So when I'm taking this function, let's say the function name is factorial, there is one parameter here, right? Now when I'm calling this factorial function with a value 5 here, now by the time we call this function, the control is going to go down to this function. And as a result, because I'm passing 5 here as a parameter, so this n value is going to be 5 to start with. So my factorial function is now being called with the value of n, which is nothing but your 5. Now my base case is checking if the n value is 0 or it is 1. Because my n value is 5 now, this condition is going to fail. So hence we are going to come to the recursive case where we have written else. And what is this? Return n. What is the value of n presently? That is your 5. And this is your recursive call. Now initially when this function is being called, the n value was 5. So now you can see we are calling the same factorial function within the body because it is nothing but known as your recursive call. And this time we have modified the parameter. Earlier the value of n was 5. Now n minus 1 means it is going to be 4. Which means this factorial function has been called recursively with a value 4. So once again the control will be taken to the beginning of this function where this n value which was earlier 5, now it has been modified to 4. Once again we will enter into this. We check this base case because n is 0 or 1, both of them fails. Hence we come to the recursive case where we see return n. What is the n value presently? It is 4. 4 multiplied with factorial function of n minus 1, that is nothing but 3. So prior to this, what we have seen is we have 5 already, and there is a temporary value we have created in the first call. Now in the second call, we are getting 4 multiplied with factorial of 3 now. So once again, we will go to the beginning of this function where n value is now 3. So now when I check this condition, base condition or base case, both of them fail. So once again, I come to the recursive call. Now this look like, now n value is your 3. So 3 factorial of n minus 1, that is your 2. So we already had 5 and 4 in the temporary result. Now 3 is added here, and now you are calling factorial with 2. So now when we go to the beginning of this function once again, the n value is now 2. Now again this base case fails. So we come to the recursive case or else case where this n value is now 2. And this factorial is being called with 2 minus 1, that is nothing but 1. So now when we go to the beginning of this function, now the n value has become 1. Now when I check this base case, n equal to 0 or n equal to 1. So this condition is being satisfied. Because this condition is satisfied, now this recursive call is going to return how much? 1. So now we can take the value that is 1 here. So now we calculate this complete one, that is 5 into 4 into 3 into 2 into 1. So which is nothing but going to give you 120. So by the end of this particular function call, which we have called here, what I'm going to get is the result is 120. So that is what we are trying to print here. So let's see one more example of recursion. Here we are trying to find out the GCD of two numbers using recursion. So here we have called this GCD function by passing two values, that is 48 and 18. So for the first time when the control goes to this GCD, so we have two parameters here, positional parameters. So we have A, there is B. So to start with, as we have called the function with 48 and 18, so A is 48 and B is your 18. So as we supposed to write a base condition or base case, we have written B equal to 0. If this is true, then it has to return value of A. Now because B is not 0, hence we come to the else part where we have the recursive call. So here we are calling GCD with B value. What is the B value? This is 18. Now, comma, A percentile B, that is 48 percentile 18. So 48 when divided by 18, we will be getting, that is 12. So now we are going to call the GCD function, which is a recursive call, by passing two values, that is 18 and 12. So now when the control goes to this beginning once again, so the A value has now changed to 18 and the B value has now changed to 12. Now when I check once again, B equal to 0. What is the B value right now? It is 12. So this base case is false. So hence we come down to the else part once again, where the GCD function is now called with the value of B. What is the value of B? That is 12, comma, A percentile B, that is 18 percentile 12. So 18 percentile 12 is going to be your 6. So now GCD function is called with two parameters. One is 12, another one is 6. As a result, your A is going to be 12 and B is going to be your 6. Now when again we start checking whether this B is equal to 0. So B is 6. Hence this will not work. So we come to the else. So now when I call this GCD of B, what is B here? 6. So B is 6, comma, A percentile B. So 12 percentile 6 is nothing but your 0. When 12 is divided by 6, the remainder is 0. Now when GCD is called with 6 and 0, I reach this beginning of this function once again. As a result, your A has become 6 and your B has become your 0. So now when I check this base case, if B equal to 0, this has become true now. So because this is true, so we are going to return A. What is the A value? That is nothing but 6. So this entire function at the end of the complete call is going to return a value. What is nothing but your 6. And 6 is nothing but the GCD of this 18 and 48.